Hello everyone, and welcome back to the second video here in our review for inference for means. In this video, we're going to talk specifically about two sample t-intervals and what is different about them compared to a one sample, and then we'll take a look at an example. So let's jump right into it. Without further ado, what is the difference with two samples? The biggest difference here is one, I need to make sure that I have two independent populations. If I don't have two independent populations, meaning two different states, two different towns, two different schools, right? The idea that one person cannot be a part of both, right? If they are dependent, meaning like the same person before and after, that is a matched pairs scenario, right? The first thing I need to make sure of is that these are two totally separate populations, no overlap. And then the second thing now is just my assumptions need to be true for both. So that's it, right? Same thing with a two proportion Z interval. They need to be true for both. Now, there is one monkey wrench that we need to introduce here, one little thing that we need to talk about. And that is that we need to talk about pooled versus unpooled in your calculator. Pooled means that we are assuming that the population standard deviations are equal. Unpooled means we are assuming that they are not equal. So the thing that's important here is you need to look for some wording in the question that may give away whether or not to use this. Typically, it is very obvious, right? Where if you're talking about two different states like Connecticut and New York, there's no reason to believe that standard deviation is the same. But if we're talking about something like SAT scores that are normed and the standard deviation is the same across the entire world, that may be a case where we assume they are the same. But let's take a look at an example problem that you might see, and let's talk about it. So for this particular one, we have two fire stations in a town, and one of the town council members believes that they have different mean response times. And so in this particular case, we have two completely separate fire stations. One's in the northern half, one's in the southern half. And I don't think I have any reason to believe that these standard deviations are the same. So the first thing it wants me to do is construct the 95% confidence interval, and then we're going to talk about this guy right here. How do I know if I have evidence or not? So for my part A, I'm going to use north minus south, right? This is the true mean, sorry, not true mean difference. This is the true difference in means between the fire stations. For my assumptions, if I take a look at the problem, it does say a random sample of 50 and then another random sample of 50. So I have random samples here from both, which is great. I apologize for my dog again. He's going to be here barking at me. They are both random, and I need both large enough for the central limit theorem. So I need them both to be greater than or equal to 30. So I know the first one is 50, which works. And I know the second one is also 50, which works. Now, for the degrees of freedom here in your numbers section, list the one that comes out of your calculator, right? The most important thing is use the stuff that comes out of your calculator. The reason for that is your T critical value depends on the degrees of freedom. And without that, you would be actually stating the wrong interval if you round down to the lower degrees of freedom. Like if I use 49 degrees of freedom here versus whatever number decimal the calculator spits out, the interval is technically different. And so This is a 2-sample t interval. And if we do this out, we get the answer of negative 2.37 to 0.37. The important thing about this interval is that it is exactly the same as a 2-proportion z interval. I'm looking for 0. And so in part B, where it's asking, does this interval support the belief of this town council member? Because 0 is in this interval, it does not support that belief. The reasoning behind that is, if 0 is in the interval, it's possible that the difference in mean response time is 0, which means that my intervals are, or that my mean response times are exactly the same. And so, if those mean response times could be the same, we don't have evidence to support this town council member's belief. So again, I hope that was helpful, and I'll see you in the next video where we start to talk about hypothesis tests. Bye, guys.